So, welcome guys. Quite of you would have seen this presentation. I would just run past it fast. So, yeah, Techmaniacs is Robotics and Electronics Club of IIT Tirupati. We do many projects. We take part in competitions, and also if there are problem statements, we take part in them in inter IT and all those things. So, yeah, as I said, we are Robotics and Electronics Club of IIT Tirupati. So we take part in various competitions. Then we have established a community where uh, if you want to engage with people with the similar interest, you can talk to them. And also, if you are taking part in any competitions, we can guide you. If you are starting with any electronics thing or robotics thing, we can guide you how to start. We can provide you resources, and also, if you want to do any projects, we can give you some basic components for that to get you started. So yeah, so our mission is to induce a technical culture in our institute, so that we focus more on innovation. So this is the Techmaniacs club structure. I am the club coordinator. Under me, there are four interest group heads of four interest groups. The four interest groups are Arduino interest group, uh, then robotics interest group, drones interest group, and electronics interest group. Two more co-coordinators whom you can contact for more information. So as you can see here, I have star mark 3D printing in the list of interest groups. This is because till previous year 3D printing was a part of our interest groups, but we felt that 3D printing has become such an important skill nowadays that members from each interest group should learn it. 3D CAD modeling and 3D printing. Also, these are the co-coordinators whom you can contact if you have any projects in mind, you want to take part in any competitions or anything. So if you want, you can take a picture of this. So yeah, so how you can be a part of this club? So club has members, and then is the core team. So for being a part of core team, there is a selection process which involves interviews and all. For this year, we have completed the process. But for being a member, you need not require. You don't have any prerequisites. You just have to take part in the events which club conducts. Like in today you have participated in robotics workshop. So you are a part. You are a member. So being a member, you have an access to the components which club has. So if you want any components you want to issue from the club, you can just contact our co-coordinators. Based on availability, they will give you the components for projects. Also, having a POR in such club is very important. Like has a great value because when you go for higher studies and all, such PORs are considered to be very valuable. So yeah, so this was a short introduction of the club. As you can see, there is my contact number. If you have any issue, you can contact me, or you can shoot me a mail on the email ID. Yeah. So I call upon Purna Chandra. He is the head of Robotics Interest Group to introduce you to Robotics Interest Group.
Knows what's robotics, so I won't be telling much. Small thing. Robotics is a multidisciplinary field that involves design, construction, and operation. You need many varieties of engineering fields. You need to which needs to work on it, and some important fields are electrical engineering for the control system, computer system for vision, and maybe mechanical and other fields for the body, types of robots. So, objectives of the club. There are three main objectives. First one is participating in events. maybe national or international competitions like Micromouse or SUAVC, sponsored by IEEE. Second one was is solving problems given by industries. This one is very important because if we solve problems given by industries, we may get funding. So that's one main thing. And the third one is providing a platform for people who are interested in robotics. So we provide components and all. So you can come to our club and try stuff. So these are our coordinators. So yeah, I'm giving the mic to Sumukh Bhaiya, who's gonna talk.
Yeah, yeah. So finally, we are starting the workshop. So I hope at least on one desk, one ROS2 is working on the system, so you can share the systems. Okay. So now basically, what is ROS? So ROS is a set of like software libraries and tools which are like foundational for making a robot. Basically, ROS contains algorithms and software packages which can be used in the robots, and like they are open source. So let's say you have to write a code for the robot to go from point A to point B, and it is like a pretty standard code which is to be written for every robot. But now in ROS2 you will have a pre-existing library which someone has done it previously and he has open sourced it. So you don't have to write the packages from scratches again and again, and you just copy paste the package which is done by someone else. It saves your time and it is also reliable. So yeah, why ROS? So first point I already explained, the codes are reusable. Second point, it ROS2 is basically acts as a communication framework to exchange data between your robots, between your control system and your robot. So the data can be camera stream or sending the positions of any accidents or whatever the robot's purpose is for. The next, if we go, the ROS provides many visualization tools such as RVIS, through which you can visualize sensor data like camera stream, lidar sensor, if you know. So you can visualize the data. It also supports simulation tools such as Gazebo, where you can simulate a robot to have a physics-based simulation where you can simulate gravity, collision between the robots. The next is it has a real-time support. So basically, if you work with any other system, you will have a latency among the data transfer. So it may affect your performance of the robot. But with ROS2, the communication is pretty fast, and I don't think so it will affect any of your robot system, and the robot can work smoothly. The last point would be it has a large community, so many people are using ROS currently. So if you face any problem, you can post it in their forum, and any user who has faced similar problem and has found a solution for it will be able to help you with it. Yeah, I am skipping some slides because we are running pretty late. We started late. So basically, okay, why we are starting with ROS2 rather than ROS1? So if I say ROS1 is like pretty old, currently the last version of ROS1 is running, and it will end by the end of next year. So not next year, 2025. So basically ROS2 is pretty new. So what they have done in ROS2 is, so in ROS1 you have to run a master node. Master node is basically a system where your master ROS is running. The other systems like other robots which are connected to the system are kind of slave to that master ROS. So the problem with this was if the master fails, the whole robotic system will fall. But with ROS2, there is no such thing as master node. Everything is connected via a single network. So if a part of the system fails, the other system will work properly. Then if you come to the middleware layer, which is the main communication layer by which the communication happens. So this TCP ROS and UDP ROS are the two transfer protocols which were used. But so if you want like a faster communication, you should use TCP protocol. But if you want a reliable and a low latency communication, UDP ROS was used. So it was like you have to choose between rather a fast communication or a reliable communication. But with ROS 2, they have solved this problem. In ROS 2, we have something named as DDS, which is Data Distribution Service. It supports both low latency and faster data transfer. So it solves the problem for both. And ROS 2, initially ROS 1 was only running on Linux, but ROS 2 supports Windows, Mac also. They are still in development, but it supports Windows. But it works best in Linux. So this is the version histories of ROS 1 and ROS 2. So currently, if you see the ROS Noetic is running, which will be running till May 25, and Humble is the not latest one, but the Humble is the version which will last till the longest time, which is 27. So in this workshop, we'll be going through ROS to Humble. So basically, how ROS architecture works is you have some sensors on your robot. Planning and control, where whatever the data was fed to the computer, it will plan and accordingly it will give the signals to the actuator to perform the task. So basically, this is a video of how Rosto is useful for mobile robots. So it will give you an idea how and what Rosto is. So basically, if you see, this is called Gazebo, which is like a physics simulator. So if you see here, there is a dot which is a robot, and here you have a custom-made world where there are obstacles, there are walls, and the robot has to avoid it. The idea is that. And yeah, here if you see, this is called the Harvest tool, which I mentioned, the visualization tool. So here you can see the different robot frames, how the robot is oriented, and this is the lidar output. So basically, what lidar is how many of you know IR sensor? Yeah, so most of you know IR sensor. So lidar is basically IR sensor which is rotating very fast. So it can give you IR sensor is like just it can give you point information there is an obstacle or not in front of it. But now as the IR sensor is rotating very fast, it can give you a 360-degree data. Where are the obstacle in a whole 360-degree surface? So here the lidar will be running on the robot, and if you see there are like these are points. So this is what when the IR sensor rotates, so it has like there will be many points which will be coming back to it, and it will plot those points. So showing where will be the obstacles. So if you see these three pillars looks like this to the robot, and then this wall looks like this to the robot. So currently, what he is doing is he is mapping the environment. So okay, how many of you are familiar with what is simultaneous localization and mapping? Okay, I'll explain. So basically, what SLAM means is the robot is in an unknown environment, and the robot will map the environment with also knowing where the robot is with respect to the environment. So in simple words, it generates a map of the environment such that it can be used later. So currently, this environment which is there, robot is unknown to the environment, and we are in a stage of SLAM where we are mapping the environment. So as the robot moves, it sees where are the obstacles, where are the free paths robot can go freely. So the gray area depicts the free paths, and the black part depicts there are obstacles. So you can see as the robot moves, it maps the environment. It knows okay where are the white portion is for the free moving path, and the black ones are obstacles. Now, once the mapping is done, you can save the map, and then we can start the autonomous navigation. So, autonomous navigation is basically robot is working on itself. Like nobody is guiding the robot where to go. We are just giving an endpoint to the robot, and the robot will navigate, avoiding the obstacles. So this was the map what we already mapped in the previous stage, and now we are just loading it. So we'll define where the robot is currently. And if you see, he just gave an endpoint like this. So you can see the robot starts moving automatically. So okay, now you might be thinking like why we are doing everything in software. So basically, we test everything in simulation first because when we do it in hardware, the things are costly and we don't want to spoil anything because we did something wrong. So we test all our codes in the simulation first because if the code is wrong, nothing will happen in the simulation. Like no cost factor will be there, and also this is fast. Like if anything breaks on your hardware, it takes so much time to repair it. So first we do simulation test every code what we will be using, and then we go to the hardware. So now, as you can see, the robot which was there in the gazebo environment in the simulation, now he has it in the real world, and we'll be running similar things again. But just now the gazebo part, the left side app will be replaced by the real world robot. So we are again in the mapping stage. He's mapping this environment, real environment. So you can see how he's mapping, how the map is getting generated in the app there. And if you see this rotating thing, this is called the lidar. So yeah, once the map is generated, again we'll just save the map and start the autonomous navigation part. So again we'll define where the robot is currently. The whole map will load, and then we can again just give the endpoint wherever we want the robot to be, and the robot will start moving autonomously. Yeah, I guess this is enough. So yeah, so okay, now till now what you saw is like very basic minimal usage of ROS 2. This is an open source robot, you can find it Turtlebot 3. So this is like a base for where you can start building from. So there can be many other applications, you can many attach many other things with it where there can be multi-purpose things to it. So this is how ROS 2 can be useful to mobile robots. Now we'll see how ROS 2 helps robotic manipulators. Manipulators are basically the robotic arms. So if you see, he has opened the same visualization tool where the map was loaded in the mobile robot, but this time he has a manipulator on it. So this is the CAD mod of the robot which is loaded in simulation. The same robot now he will have in the hardware. So now you can see the same robot is in hardware. This is also popular open source robotic manipulator called UR5. So now if you see, like whenever the manipulator is moving, the same joint angles are also there in the simulation. So the simulation is moving exactly as the real one. Yeah, I guess this is enough. Okay, so I guess enough of theory session. So we'll start with the hands-on session. So we'll be using two packages named Turtle Sim and RQT in this session. So I request you to install Turtle Sim and RQT using these commands. Just type these commands in your terminal. I guess you can see, right? Uh, hello. Yeah, so I guess you all will be facing a problem, maybe ROS2 command not found. So actually you have to workspace every time you open a new terminal. But you can skip that process if you enter a command in your bash rc file which runs every time you open a new terminal. So I request everyone to open your file manager and press Ctrl H. You will see a file named .bashrc. Please open it, and in the bottom of that file, in a new line, you can write this command: source opt-ros humble setup.bash, and just save the .bashrc file and close that. And now you can open a close the existing terminal and open a new terminal and check that it will work. Okay, so now we'll start with the how. So there will be a few terms, so try to understand it. Starting with the first element called node. So first of all, in simple language, if I need to tell you, so node is each and every program what you will write run the motors. One node will be assigned to run the LIDAR, the main system. One node can be the remote control if the user has the control over it. So each node has a separate purpose, and they will be working on that. And each node receives data and sends data from the various pathways what we have in ROS2, namely topic, service, and actions. We will be seeing topic, service, and actions in the subsequent slides. So as I already told you, the robotic system is comprised of many such nodes which are working together. So this is like animation. You can do okay, yeah. No, it's and no node is acting as a master node. That node can send data also and receive data also. This is like very small part of your robotic system. So for this example only, that is just sending data and these two are receiving data. For example, if I say, let's say that node is your camera node, which is sending your camera data to your system. So let's say you have two different systems which are doing some two different computer vision algorithms through your camera. So each of them is getting what is being streamed through your camera, and there they are performing their separate computation. So there is no master node here. It is either sending or receiving data or both. So okay, we'll start with hands-on. Yeah, so as we have installed the turtlesim package, we'll be using that. So I request you to run the first line, first command. Is ROS to run turtlesim underscore node. So I guess once you enter the command, you will be seeing a blue window with the turtle spawned in it. So yeah, okay. So okay, now you ran the command, but what this command means is basically first is ROS2. We are telling the system, okay, this is a ROS2 command. Then we are run means we are going to run an executable file. Then turtlesim is the package name where your program which is to be executed is there. And then last is your executable name, the program which you want to run. Now we are learning nodes, right? So still we don't know what nodes are there in the window you are seeing with the turtle. So now if you open another terminal and run ROS2 node list, it is going to show you what nodes are currently present in the system. So yeah, please run this. So as we are running only one window, the turtlesim window, there is only one node existing in a system which is and run this command which is ROS to run turtlesim turtle teleop key. Basically, this will open a controller for your turtle through which you can control your turtle. You can move it forward, backward, change its orientation. So again, if you see in this command, turtlesim is the package name and turtle teleop key will be the executable what we are running. So is everybody finished with this? Yeah. So again, now in the terminal where you ran the ROS to node list command, if you go again and again run ROS to node list, now you will see two nodes. So yeah, please. Hmm. Yeah. So I guess everybody is till this stage. So okay, now let's say if you want to spawn another turtle in the environment. So now if you keep the turtle name as same, like if you keep the same node name as turtle sim, so when you refer turtle sim, you don't the system doesn't know which turtle sim you are referring to. So generally, when we spawn a second robot in the environment, we change its name. So how you can do this? You can run ROS to run turtle sim node, and you can change the argument name. Like you can change the node turtle sim to any name what is specified here. So let's do with my turtle. So yeah, please run this command. Okay, where are the previous commands what we ran? No, no, like you don't have to close this. Okay, guys, don't close the previously ran commands. The teleop, the first turtle sim node what we ran, the teleop key, and this will be the third command which will be running. And there will be a fourth terminal where you are running ROS to node list. So don't close any of the terminals. In the terminal window on the left upper corner, there will be a button to add a new terminal. So, okay, everybody ran the commands till here. Till there are three nodes visible in your node list. Yes. I'll consider it. So okay, now till now we just saw what are the different nodes and we just saw their names. So if you now to get more information about what each node does, like you already saw in the animation previously, like each node is connected to a topic, service or action. So now to get the more details on which node is connected to which topic and service, so you can write this command ROS to node info and the name of the node which you want to get the information about, and you can press enter and see. Okay, so if you type that, I guess you'll be seeing something like this. Yeah, so I hope everyone is seeing something like this. So if you see, the first line says my title, which is the node name, and then it actually it gives details of what all it has published and like where all it is sending data and from where it is receiving the data. I guess currently you will see it like a pretty complex thing because you don't know what are topics, what are services, what actions. So I guess it's better to come back at this slide at the end of the session where you will know all what these three things mean and you'll be able to understand it better. But yeah, something should like this be visible in your system. Yeah. So okay, we'll come to the next element in ROS. First was node, what we saw. The next is called topic. So basically, what topic is like two nodes communicate with each other via different ways, which I already told. One is topic, one is service, and one is action. So for continuous data transfer, like where the data is to be transferred seamlessly without any intervals, like maybe for camera, for lidar, for any other sensor which has to send the data at a uniform speed, we use topics. So topics like to a topic, someone will be publishing, someone will be sending a data to topic, and another node will be receiving the data. So when you send the data, it is called publishing the data, and when you receive a data, you are basically subscribing to that data. So there are two terms here: publishers and subscribers. So again, I guess this animation will show you better. So there is a node which is publishing the data to this topic, and these two nodes are subscribing to that. Now the like this whole system can be one to one, like one publisher, one subscriber, one to many, like one publisher and two subscribers, and it also can be many to one, like there are two publishers which are publishing to a same topic, and then there are two nodes which are subscribing also. So any type of function is possible here. Okay, so do you guys get what topic is? So we'll go to the hands-on part of it. So okay, currently what are the terminals are open for you? Do Control C and then close the terminal. In each terminal, do Control C to exit the program and then close the terminals. And once you close the terminals, open a new terminal, run the command again, ROS to run turtle sim node, and in a second terminal, run ROS to run turtle teleop key. Yes, I guess By this time you ran both commands. Now, previously we saw list of nodes by command ROS to nodes list. To see the list of topics, the command is very similar, ROS to topic list. So in a third terminal, now you can run ROS to topic list to view the list of what are the existing topics in our system. Yeah, so is everyone getting the list of topics? Hmm? Yeah, in a third terminal, please run ROS to topic list to see the list of topics. Okay, so I guess you all have got the list of topics what we have. So if you see the first two topics, which are parameter events and ROS out, these are default ROS two topics which is used for the backend communication. So currently in the basics workshop we don't want to go there. So we'll see the three topics which has turtle one as the prefix. So first is command well, which is basically abbreviation for command velocity, which refers to the velocity of the turtle. So when you press the arrow key, the turtle moves, right. So it has a velocity. So this topic stores the velocity for the robot. The color sensor topic is for the color of the robot, which you will not use. And the pose refers to the position plus orientation of the turtle. So position is the x and y coordinates in the frame, and orientation is the orientation along the z-axis. So now to the first command well topic. Not different. The teleop key what you ran, which is like the keyboard for your turtle, is publishing some velocity, and the turtle sim window is subscribing to that velocity to receive the velocity and perform the action to it. So now to see it in a more visualized way, you can we can use the RQT package what we installed initially. So in a new terminal, without closing any existing file, run RQT underscore graph. So this was just a small command. So once you run RQT graph, I guess you should be able to see a window, maybe not exactly like this. Is a window opening? So yeah, so if you're not seeing something like this, you can see checkboxes on the top right. If it's not checked, just tick on all the checkboxes which are available for you. So after like checking the boxes, is something similar visible in your screen? Also
Okay.
make
So
sure to write is everyone seeing something similar which is appearing on your screen. Like we saw that once you send data, the teleop is sending the data and it is received in the window topic, and then the window to see actually what is the data being sent. Now are you getting something? You can open a new terminal something similar to this, and don't close any existing terminals and run this first command ROS to topic like echo the text to like echo is like reading the data which is being published on a topic. So we are reading the data which is published on the topic command well. So please run that command, which is appearing on your screen. So once you send data, it goes to the topic and it is received in the window, and then the window is performing the action to move the robot. So now I guess if you run the command, you won't be seeing anything. The cursor will be just blinking in your terminal. That is because no data is being published on the topic. So now once you go to the terminal where you ran the keyboard, like we saw that you go to the terminal and sending the data to command velocity topic, and then come back to the terminal where you ran this echo command. You can open a new terminal. Now you will see a data and something similar, not the same existing terminals. And you press upper arrow key, you will see something like this. Topic. Echo you press any other arrow key, like you will have some different echo is like reading the data which is being published on a topic. So we are reading the data. Should we go ahead? Reading the data which is published on the topic command well. Okay. So please run that command. So now I guess if you run the command, you won't be seeing anything. The cursor will be just blinking in your terminal. That is because no data is being published on the topic. So now once you go to the terminal where you ran the keyboard, you go to the terminal and press any of the arrow key, and then come back to the terminal where you ran this echo command. Now you will see a data which is something similar, not the same values. If you press upper arrow key, you will see something like this. But if you press any other arrow key, you will have some different values. But our data should be visible like this. So is something like this similar visible in your terminal? Yeah. Okay. Okay. So now to get like now we saw what is being published on the topic. But now if you want to like get the info of what exactly the topic is doing, you can do ROS to topic info and the topic name. So you can do this for the command will topic. Okay, so we'll start with the second subscriber was the echo one, the first was topic, which is like the most common way of communication. Right? The next one is service. Subscribing first and then basically service. The topic is running every time. That was the second subscriber for whenever the robot is running, the topic is transferring data from one end to the other. But service is a pretty niche case. This was like whenever the data is requested to a service, then only it sends a request. Sorry, response. If you have whenever someone requests the data, topic, it will compute will move to the next whatever request is mentioned, and it will then send a response. So, how a format or a structure of service message looks like is it will have a request message which the client will ask, and then it will have a response message which the server will send. So, service has two parts named server and client. Client will be the one who is asking anything, and server is the one who does the computation and returns a response. So, for example, let's say a client gives two integers a and b and asks for a sum of both integers. So, what server will do? It will take both the integers. So, in the format, it will look like it is taking two integers a and b, and it will do the computation of a plus b, and it will return the sum. Start with the second. So, the response of communication. The first was topic, which is like the most common way of communication. The next one is service. And so basically, so service, the topic is running every time. This is a response message, and whenever the robot is running, the topic is transferring data from one end to the other. Data, but service is a pretty niche case. Like whenever the similarly any other to a service, then only it sends a request. Any other client can also request a message. It will whenever someone requests the data, it will compute the request to server, whatever and then come as a response, and it will then send a response. Now, if you see here, the difference between topic and service is how in topic there can be many structure the many to one or many to many is possible. It will have a request message. Nodes the client will send data to topic, and then it will have a response. There can be only one server possible. There can be many two parts named server and client. One server will be possible. Client will be the one who is asking anything, single node only, and server is the one who does the computation and returns a response. So, for example, let's say a client gives two integers a and b and asks for a sum of both integers. So what server will do? It will take both integers. All the format it will look like it is taking two integers a and b. Other than that, close all the terminals. It will do the computation of a plus b, and it will return the sum. So the response of this service will look like a sum of a plus b. And so this is you can how visualize it. So this is a response message, and this is a client. So it's requesting a data, and then in the response it will receive the data. Similarly, any other client can also request a message. It will go through the similar thing. It will first go as request to server and then come as a response to the client. Now, if you see here, the difference between topic and service is in topic there can be many to one or many to many is possible. Like many nodes can send data to topic, but here there can be only one server possible. There can be many clients, but only one server will be possible. So all the requests will go to a single node only, but the request can be asked from different nodes. Like we saw the list of topics as ROS to topic list, nodes as ROS to the hands-on session for it. Similar command is for service also. So if you run in a new terminal ROS to service list, if you can list all the services, you can close all the terminals except this turtle sim node and tell your key. Other than that, close all the terminals, and by close I mean press Ctrl C and then close. So yeah, once you run the ROS to service list, I guess you will be seeing many services. Again, the service with the underscore parameter in it are not necessary at this stage. They are the services. So yeah, Now, like we saw the list of topics as ROS to topic list, nodes as ROS to nodes list. Similar command is for service also. So if you run in a new terminal ROS to service list, it will list all the services which are available currently. So yeah, please test that. So yeah, once you run the ROS to service list, I guess you will be seeing many services. Again, the service with the underscore parameter in it are not necessary at this stage. They are the services when you go deep in ROS, you should get this, but currently it's fine not to get this. So the services what currently we'll be seeing is the first four: clear, kill, reset, spawn, and turtle one set pan, and turtle one teleport, absolute, and teleport relative. So by service, like by the name, if I can tell you, is clear will be like once you move your turtle in the space, it will draw the white lines right behind it. So with the clear service, you can clear that. With the kill service, you can just remove the turtle from the workspace. With the reset workspace, you can move the turtle back to the position where it was spawned initially. And with the spawn service, currently when you spawn the robot, it is spawning at the center, right? So with the spawn service, you can spawn it at any point in the window. Yeah. So now to get like more information about any of the service, so we can what we can do is ROS to service type and then the name of the service where you want to get information for. So please run the command ROS to service type and slash clear. So yeah. So once you run it, you should see something like standard services, service and empty. It is very similar to what we saw recently. Yes, yeah, here. So when we ran the topic info command, we saw that the type of the topic was twist message, where the twist refers to a specific format. Similarly, empty will also represent a similar format, but by the name you can understand empty means nothing will be there. Because for the clear command, it is clearing the path which is being made by the white line. So you don't need any specific argument for that. You just call the service and it will clear the lines. Now let's say you don't want to, like here we have to manually type one service and see what type of the service they are. So to see type of service itself in the whole list of services, you can modify the ROS to service list command to ROS to service list and then space dash T. It will list the services, also the type, which type each service is. So you will be seeing many services, but the important ones which are what I already told you are this. And so you can see that the clear was having the empty service. So now if you want to see what each this service type means, like we got the service type as empty. So what does this empty signifies? Like the twist message what we saw in topic represents like three linear velocities and three angular velocities, right? So this empty will also represent something. So what you can do is ROS2 interface show and then the type of the service. You can run this command to see the data what is in the service file. Yeah. So I guess you will be seeing something like this triple dash, which is like nothing. So previously when I told you the format of the how service format looks like, it is a request and a response which are separated by triple dash. So the empty service, the empty service file has the thing. So it doesn't need any arguments to perform the service. That's why it's empty. But now if you run the similar command for another service type, like for the spawn service, the service type is turtlesim slash srv slash spawn. So if you run ROS to interface show on that service type, you will get another format. So please check the format. So I guess you ran the command for the second service type. So you will see format which has like first float 32x, float 32y, float 32 theta, a string name which is optional, and then a triple dash and one more string name. So here what this format means is So as I already told you, the spawn service is for spawning the turtle at a location what you want. So how you will specify location is by giving the x and y coordinates where you want to spawn the robot, and theta represents the orientation of the turtle, how you want the orientation of the turtle to be. And if you want any specific name for the turtle, like we had turtle one, right? Turtle one, right, as the prefix. So if you want your own any name, so you can write the name for that. And if you don't write, it will auto generate a name. So yeah, any doubt till here? Now we'll be calling a service. Yeah. So now to call a service or like request anything from a service, now like we are the client and a service exists. So how we'll do that is we'll do ROS to service call, the service name, the service type, and if it has any arguments, we will be giving the arguments. So let's start with calling the clear service, which is used to clear the white line which is drawn by turtle. So if there is no white line currently, I request you to move your turtle so that some white line is there. And then we'll run the command ROS to service call. We want to run the service which is clear, which has a type of standard services service empty, and it doesn't have any arguments what we already saw previously. So try running this command and you will see the white line from the turtle window goes away. Yeah. Okay, so we'll go next. So this was a server with like we called a service which doesn't has any arguments. Now we'll try calling a service which has some arguments in it. So we saw a spawn service, right, which is used to spawn a turtle at any location what you prefer. So the format will be similar. ROS to service call, the name of the service which is slash spawn, the type of the service which is turtle sim srv spawn, and then the arguments. So if you remember, here we saw what the arguments will be. Yeah, here we saw the arguments will be a x and y coordinate, a theta value, and a string name which is optional if you want for your robot. So in the similar format, we have to specify the values. So in double inverted commas, what x value is, what y value is, the theta value which is in radians, and the name, and we are keeping it blank. So try running this command. You will be seeing something this as a response in your terminal. And once you run the command, there will be another turtle spawned in your window, which is at the almost like lower right corner, lower left corner. Sorry. So requester means you. So you requested that there should be a turtle spawned at the location x2 y2, orientation of point to radians, and name is blank. So in the response, what came is a turtle is respond with a name turtle2. So if you remember, when if you see back, yeah. So in the spawn spawn type, the output was just a string name. So if you give any string name, it will display that, and if you don't give anything, it will auto generate, right? So yeah. So in the response thing, it gave the output as string name only, and it auto generated as turtle2. Okay, so one last section is remaining. So let's start that, and let's try to finish before 11:30 so we can take the bus. So any doubt in services? Yeah. So now we'll go to actions, which is like last for the way of communication. First was topic, next was service, and the third one is action. As I already told, topic is like most commonly used, services is less frequent, and actions is the least frequent which will be used. Mostly action is used in the packages which are open source packages which are like for heavy computations. So okay, I'll tell first what action is. So if you remember, service is when a request is being asked to the server by a client, it gives the it does the computation and gives the response for that request. So action is something similar, but action is you can say expansion of a service. Like let's say a competition takes large enough time to do the computation. So it will give us feedback. Like what is the status at this time instant? Let's say a competition takes 10 seconds. So there will be a feedback every 0.1 seconds. It will tell where the competition is currently. Let's say we tell the computer to print from 1 to 100. So it will how the message format will look like is request, a response, and a feedback. So if you see request and response is same as service, just what is added is feedback. So yeah, about the example I was telling. So if there is an example to, let's say, print from 1 to 100. So the request is, let's say, made like a number, and till that number you have to print. That is the computation. So a request is made, 100 is sent. That means you have to print from 1 to 100. So response will be like 1 comma 2 comma 3 comma till 100. But let's say computer takes some time to print it. In real life it won't take, but I'm assuming this is a pretty high computation and it takes some time. So what feedback will do is, feedback first feedback will just say 1. Next feedback will be saying 1 comma 2. Next feedback will be saying 1 comma 2 comma 3. So this feedback will go till 1 to 99 also. It will also give a feedback of 1 to 100. And when the computer sees that okay till 100 we have generated the numbers, then a result will come which will again print from 1 to 100. So feedback is just giving us information about the time steps where the code is running. So it also has two parts, server and client. So basically they both are same. So here I have explained one more example. So how many of you know Fibonacci series? Yeah, so basically the sum of last two numbers is the next number, right? So let's say a client gives a number, a random number, let's say 5. So we have to generate the first n terms, like first 5 terms of the Fibonacci series. So here what the server structure will look like is, there will be order which is received by the client, and then there is a response sequence and there is a feedback sequence. So how feedback will look like is, first feedback will print 1, next feedback will print 1 comma 1, the next will print 1 comma 1 comma 2, then 1 comma 1 comma 2 comma 3, and the last feedback will look like 1 1 2 3 and 5. Once this like computer knows okay we are at the result, then it won't give any more feedback, and then the last response or the result will come, which will again list the same sequence 1 1 2 3 and 5, which is same as the last feedback. So this is pretty much what action is. So it just varies from service as it gives a feedback. So this is a display. So once there is a request sent, action, the server also sends that it received the goal. Now there will be the feedback loop running. So if you see, there will be feedback which is going back to the client. What is going on? Like let's say the Fibonacci series thing only, it is printing one iteration from for the Fibonacci series, and at the end, once it is completed, then a result message will come. How much time will it? Yeah. So once it is completed, then the result message will come to the client that your whatever action you called is being completed. So I guess it looks bit complex, but now you can see that the action is divided into servers and topics only, where the server is the request and response, and the topic is the feedback, which it is giving it every iteration. So we'll start with the hands-on part. So again, you can close all the terminals. Just leave the turtle sim node and the teleop, and use Control C to close it. Yeah, okay. So now if you go to the terminal where you are running the teleop, you will be seeing like something like this from start. But what I guess till now what I told was just to use the arrow keys to move it. But there are also these keys which are used for the rotations of the turtle. So if you press any key, the turtle will rotate accordingly. And F F is used to cancel the rotation. So I guess in the keyboard, these all the keys will be surrounding F. So like whenever you press any key from this to rotate the turtle bot, you will receive something like this in your terminal that the rotation is being done successfully. Try pressing any key and you will receive this. Now what you can do is to test the cancel rotation button, which is F. Just press any of this key and quickly press F to cancel the rotation before it completes the rotation. Just try that and you will see that the rotation goal is being cancelled. It will print as the rotation goal cancelled. Yeah, so is it fine till here? Yeah. So also, I guess I didn't tell you, for service, there can be only one request at a time. As I already told you, there is only one server, so it can process only one request at a time. But let's say there is a competition which is going on for a first request, and a node sends another request. So what will happen is the first request wherever it is, it will get cancelled, and the second request will start processing. Similar thing will happen in action also. So you can try that. What you can do is you can press any of the key to rotate it, and before it completes the rotation, press any other key which rotates it. So then the terminal will print that the previous goal is being aborted, and the next iteration is being received. So it's finally right. Okay. Yeah. So now we come back to the point initially where we did the node info part, where we got a bunch of things here. So you can again run ROS2 node info and the node name, which is turtle sim, and run this in a new terminal. So I guess you will be seeing something, a big list like this. So currently you can ignore everything which has a parameter in it. In a line, if you see parameter, currently ignore it. We don't require that at this level currently. So okay, now to start, I'll explain this. So TurtleSim node is being subscribed in the subscriber. It is subscribing the command well, which we saw that it takes the velocity from the command well topic and then executes it, right? Then it is what it is publishing. It is publishing the color sensor, the color of the turtle, and it is also publishing the pose. Pose I already told. Pose means the x and y coordinate and the theta orientation of the robot. So that the turtle sim node or the window is also publishing the pose where the robot is currently. Then it is also running the service servers like this, the clear, kill, reset, and spawn. So whenever we call any of this, the window acts, right. So it is the servers running. There are no clients running through the turtle sim node because we are not asking anything through turtle sim node. And it is also running an action server. So what you just did was, where you were rotating the turtle, you were calling action. So it has an action server running and none of the clients. Now to get familiar with it, you can we have another node, right? Turtle teleop. So you can also do the node info for turtle teleop or teleop turtle. Yeah. So once you do the node info for teleop turtle node, you will see in subscribers there is one parameter. You can ignore this currently. In publishers, if you see, there is this one command well. So we know that our keyboard is publishing to the command well topic to which the turtle is acting. Then in service servers, if you see all our parameters, we can ignore this currently. There are no clients also. There are no action servers also running through keyboard. But there is one client which is running through keyboard, which is the rotation part. So we are requesting the turtle window to rotate according to the key we press through keyboard, right? So keyboard is a client. So through a client, we are sending a request to the window to rotate accordingly. Any doubts still here? Last two three slides. So similar for action also, to get the list of action, it's just ROS to action list. And you will get only one action because there is only one action which is there currently in our system, which is to rotate the turtle. And again, if you do ROS to action list dash T, you will receive the type of the action also. And similar to service info also, if you do action info about the type of the message, you will get the information about a message that it has one client and one server. Server will be always one only, but it specifies what server it is. And there can be multiple clients, but currently there is only one client, which is our keyboard. So it specifies teleop turtle node is one client for this action. And to know more about the action type, to get the format of the action type, we ran interface show, right? So it's similar ROS to interface show, the type of the action, and you will receive something like this, which tells the theta. Theta is the direction what you want. So when you press a key, it is assigned to a specific rotation, specific orientation. So that will be being sent as theta. Delta is the final angle what it is rotated. So this is the response. The second is the response, right? And the third one is remaining. This is the feedback. Feedback which will be running when you rotate it. So now, like if you want to, uh, till now we sent a goal with the keyboard, right? Now if you want to send a goal with a command with the terminal, so we can again like we called service. Now to call action, what we'll do is ROS to action, send goal, then the name of the action, the type of the action, and the value. So it takes only one value theta. So we'll just give theta as pi. Okay, no need to type this command. I'll tell the next command to type. So what you will see is which is something similar. Like it is sending the goal first, and it has a goal accepted ID. So it will return you ID that it accepted a goal. What we saw in visualization, right? That the goal is first sent, and then the action server sends it back saying that we received the goal, and then there the feedback loop starts. Yeah, so it's something similar. It says us that the goal is accepted with a specific ID, and then it directly shows the result and it says goal finished. So you might be wondering why there is no feedback. So it's optional, like we can opt for having a feedback. So if you run the same command and just add double dash feedback at the end, now the terminal will also give you a feedback. So now this you can try, you can type this command and see it will be like sending a goal, then again the goal is being accepted with ID, and then it will be sending feedback of what feedback it is, and once it is reached, it will be saying result and the goal is being succeeded. So try the first command. This feedback will go on for you. The three dot represents this is a long list. Yeah, so is it working? It's showing feedback. Okay. So yeah, I hope everybody is here, and I guess we are at the end of the session also. So I'll just tell a few things. So currently, you might be thinking ROS2 is going a bit complex here, like it's just the basics and it went pretty complex. But in your when you'll make robots, you won't be using actions. I'm saying it's just you should know what this means. If you if you cross this action, you should know what the action does. Service also, it's very rare you will use it. You will be mostly using topics, and topics you saw it's pretty simple. You are just sending and receiving, nothing more. Mostly it will be topics. And how ROS is helpful is you saw the first video, right? The mobile robot moving. So once you make it, there are like many add-ons to it. You can attach a robotic arm on the top of the manipulator itself. You can link two robots and perform like a task which involves the collaborative task with both the robots. And yeah, so this was like basic introduction. We just saw what each topic server action means and how we can communicate it. But still, I didn't show you how we write a publisher, how we write a subscriber, how we write a server and client. So everything here was taken from the ROS to Humble documentation. So I took a few things because everything I can't summarize in a one PPT. So I'll share the slides, I'll also attach one slide for the links, whatever I referred. So I request you, if you want to continue to ROS, I request you to finish the tutorials. Like in the ROS to Humble website, there are few tutorials named as beginner and intermediate tutorials. If you finish these two sections of tutorials, you are trained enough in ROS2 to start using ROS2 on a real robot. So if like many of you are interested from the people came here, I can take a follow-up session where I'll show how the simulations are made. We can try and test a few simulations in your systems like this hands-on session. But till then, you should be able to know how to write a publisher, how to write Fiverr. Simply, you should finish beginner and intermediate tutorials. So we'll take up a poll then, and we'll see. And I'll Jack will send it from Techmaniacs ID the slides. Yeah, we are done. So just write your roll number for attendance. And yeah, you can go.